those of you guys just joining us, if you want, I had the kiddos coming in and here and chilling, reviewing how to do matrices on their calculator, because there is a class in college called linear algebra required for practically all computer programming, engineering, econ, physics, math, applied math, majors. Linear algebra goes back to matrices. Anyway, not sure if you're using your graphing calculator in those classes, but I did do an RREF problem, and kiddos went and reviewed how to do RREF in their matrices for those that were interested in here on time. But we're now in BC. So we reviewed really quickly that in Google Classroom, wherever we are. Oops, let's not do that. You guys have 2 announcements that you need to pay attention to, but as we're doing that, I also have the webcam opening up because homework is not due today, it is due tomorrow. But that's kind of weird, because in our notes, I think we basically finished, right?
Yeah.
Or did we?
Yeah.
Oh! 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 Okay, do I have practice? Yes. Now pause. Those of you that have written down homework, let's see if any of this practice is homework or close to homework, because that is ideally what we're trying to do, is get some more practice in. And another reason why we're taking a whole nother day on section 10.2. I'm going to zoom on in, single page display. If you want to do this in your notes, that's great. Oh, we like these. Oh, this is nice. I want you guys to play around with this one just to start off class. It should go fast, unlike the first problem in homework. Because the first problem in homework, if I was to open up my webcam, remember I showed it to you quick yesterday? And I asked you, hey, square root of 1 plus x squared. Is that one of those nice memorized ones? Because we have this nice forever card, and they're ones that we can memorize and like do quicker because it's awesome. But does it match up with any of these? No. Oh, is it a derivative or an integral of one of these?
No.
No. So what's the other way? Yeah, what's the other way of doing it? Take derivatives? But how many derivatives? Well, you have to do a 4th order Taylor polynomial. If AJ was here, I would ask AJ, how many terms do we have to do? And she would say the one up until the 4th derivative, right? That was the thing I keep on asking her because she got it right a couple days ago. So to do a 4th order Taylor polynomial, we have to take 4 derivatives. Now, how fun is taking 4 derivatives of number 1? Not fun. AJ was in here taking it. Dean was in here doing it. And then you were too, right? All 3 of you were taking those 4 derivatives, and it was messy. Now, I was talking about Google Classroom just a second ago, wasn't I? And when I was talking about Google Classroom, I was mentioning the fact that maybe you should check out what's in Google Classroom. One of them, once again, yes, the sweatshirts and t-shirts, as long as I get out of here by like 4:30 today, will be here tomorrow, will be available for you to pick up as soon as you have paid, so bring money. However, in the homework, wasn't there like a little extra something that's not usually there?
The answer.
What was all here? The answers for you to check and come with questions for. This is a tricky section. Special McLaurens, that really important forever card, that Endeavor card, I should say, that we've written down, right? But what else was in there? Oh! Now, for those of you that did go through and do the 4 derivatives, you did exactly what I expected you to do, so good job. I'm proud of you. I hope you got there. But for those of you that haven't yet, I feel like I shouldn't reward you. But for those of you that are looking for how to be creative, we cannot make this look like a geoseries. It's not a 1 over 1 minus r. We can't make it look like any of the other special Maclaurens with deriving or integrating, but we can use the composition idea of, well, what if we were to go simpler, get the Taylor polynomial, the Maclaurin, for this guy, and then just be like, x squared, boop, 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 boop. Can we still have tricks, even with the harder ones that don't go straight to answers like the Endeavor card? Yes. Now, what math did that save? Because those of you that struggle, that saved a lot of math. What if you hadn't done this? And you hadn't done this? and you hadn't made a Taylor polynomial out of him and then said, hey, so x squared, boop, 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 done. Would it trig sub? I wouldn't be integrating. Don't do that. Do you want to integrate? No. You would have just taken a derivative of f, right? And what would f prime have been if you had done it that way? Wouldn't you have brought down the 1/2, -1/2, but wouldn't you have had a u prime? What's the struggle when you go to do f double prime? What do you now have to do? Okay, I know. But don't you have to do quotient rule? And then to do the third derivative, wouldn't you have to do another quotient rule and then another quotient rule? Which way looks nicer? Using power rules repeatedly? Because u primes are just one, and then a composition, or doing nasty quotient rules. For those of you that were in here working yesterday, it was not that I was being mean. I honestly hadn't remembered that there was a trick until I opened up the assignment, and I was like, oh yeah, that's way easier. But I would have been right along with you taking 4 derivatives and being like, well, that was not fun. So, can you be a bit creative with Taylor polynomials? Yes, but only once you get familiar with them. Does that make sense? Because otherwise, I mean, where else in math is it all of a sudden like, let's just pretend u and then plug u in later? I mean, sometimes, but Taylor polynomials, it's one of the first places in a long time that we've been able to have that kind of fun. Anyway, that's there. It's there for a reason. It's there to be helpful. And then this was what I said last night. We're going to have a partial work day. You guys have your questions open, right? So I have in your notes, oops, where'd it go? What problem number was this? 22 is a homework problem? Is it the exact same problem? Huh. How you guys doing on this one? You doing okay? Why is it easy? Plug it in, right? Plug it into the Taylor polynomial formula. Okay, so hold on. That one's pretty easy. Let's see what else we have. Is number 24 a homework problem?
Yeah.
Yep. Is this one easy? No. They want us to find 10 derivatives? Oh, well, it's better than last year. That was 27. I always change the number. I don't know what is the actual number? I think it was 27. It's better than last year.
It was for sure.
But what's the problem in this problem? Do we even have a function to take a derivative of?
26.
Oh, it was 26. Thanks for looking at that. 26. Oh, because think of it as the evil problem. 26. Okay. Pause. We don't even have a function to derive. So how are we going to find the 10th derivative? Pause. Find the first derivative. How are we going to find the first derivative? Derive what?
No, but using this one. Looking at the second one, it should be after one.
You have to get used to them. What's staring you in the face? Wait, but it doesn't quite perfectly match up. Hold on, wait, right? Why is he there? I don't know. But can we set it equal to him and say, okay, well, who's supposed to be going by the x? F prime. Well, who's next to the x right now? So can't I say f prime of 0 equal, no. F prime of 0x is equal to x all over 2 factorial. Can you guys solve for f prime? I hope so. Because if you divide both sides by x, can't you just say that f prime of 0 is equal to 1 over 2 factorial or 1/2? I mean, I would just do 1 over 2 factorial, just trying to stick it to the man. But wait a minute, hold on. So what's the 10th derivative going to be? Are they expecting me to jump straight there, or maybe trying to find a pattern? Uh-oh, I better find a pattern. Maybe go one more? So what if we were to go to f double prime? Isn't f double prime all over 2 factorial? What's that supposed to equal?
X squared.
The x squared, and what's the x squared coefficient? 1 over 3 factorial. Uh-oh, so what's f double prime? So f double prime is 1/3, f single prime is 1/2. Do you want to keep on going, or do you think we have a pattern? F triple prime over 3 factorial equals 1 over 4 factorial. Remember, or multiply 3 factorial over 4 factorial, that's 1/4. Guys, what's the 10th derivative going to be? 111. But could it take you a couple terms to see the pattern? Probably, especially with those factorials not showing up in the first one in my formula, but showing up in the second one. So this one would be 2 factorial over 3 factorial. Next one would be 3 factorial over 4 factorial. The 10th one would be 10 factorial over 11 factorial. So 1 over 11. Letter B, is this a hard one?
Just type that.
Ah, we just could distribute x, x, x. Oh, that's not bad. Write g of x in terms of a familiar function without using series? What card is it that has like all those special ones? See if it looks familiar. You're welcome. Uh-oh. What about this one? How do I find a Maclaurin? Oh, I have to find f, f prime, f double prime, f triple prime, f... Wait, what's the other one? Substitute. Does it look like any of the special ones in endeavor number 26? What did we do yesterday? What does it look like?
1 over 1.
Can't we start here and say, oh, that's a geoseries, starting at 1 and then multiplying by x every time? I like him. Can I make him into him with a composition of functions and then times 2? Then letter B says, do what term by term once you have the series? Integrate, integrate, integrate. Maybe not so bad after all. What's this guy? Ah, we wish this guy was at the beginning of homework.
Yeah.
Even if I hadn't shown you the hint in homework, you would have eventually gotten to the hint that would have made number 1 easier. Very sneaky. I like this homework. You would have solved it the hard way, gotten down to 27 and been like, no way. So they said to basically build it up. I think I gave this one because in years past I didn't give the hint. I think it was last year just with that class. A lot of them saw number 1 and then stopped, and I was like, okay, keep going. Anyway, 27 gives you the idea of if you need to get something nastier, you can start with something simpler and then make a composition, plugging in that x squared. But the interesting part is going to come in part C, right? Because A is the hint I just showed you. B is finding what number 1 actually was. What does C say to do? Come on, use your calculus now. What does C say to do? What does it give you? Where does it want you to go? It gives you not another function. It just names this as some other function's what? And what is it asking you to find? How do I go from a derivative back? And how do I integrate something that has a power series? Term by term? How do I use the clue? Oh, that's the question. Okay, ending here. What does it look like? What does it look like? An FRQ. But it also looks like one of the, well, it's an FRQ, but it also looks like, yeah, David's right, one of the endeavors, right? But we can't let the whole class miss out on this experience of an FRQ with power series, right? Why should you be vigorously agreeing with me? Because what does that mean if we should save this for everybody else to come back?
It's going to be on the exam most likely.
Well, yeah, there's definitely going to be a Taylor or Maclaurin on the free response, but what does that mean for you guys in your class today? Instead of spending time on this, what could we spend time on instead? There we go. Now there's a light bulb moment on homework. Now, for those of you that are done with homework, Google it. You can start researching Lagrange airbound. It's where it gets quite interesting. I'm going to freeze it on the screen, but for those of you guys that are like, yeah, that homework that has not been started yet, maybe we should be starting homework. So I'm going to go ahead and in Google Classroom right now, I'm going to post a few scans because I have a couple books, but I don't have enough for everybody. I'm going to edit and insert pages. You guys can be writing down Lagrange airbound. We'll make everybody else tomorrow write fast after we do the FRQ. But I'm going to go ahead and...
No.
Yeah.
Please. Put them out. Why? God. Alright. I got it. Yay. Why don't you take a picture of it? It's so open. I don't want to write it.
Yeah.
Now. I want to work on the homework.
I'm
I'm going to teach you. I can teach you, Kevin.
Well, I mean, you like the notebook, though, better, right?
It's just a normal. Yeah. It's just a normal notebook.
When was the last thing you said?
It was just a normal notebook. It's like all the ones that I use.
And then it was a wide rule.
Cry.
Where'd you get the textbook?
I think they have one that's like checkerboard.
Oh, because that would, you could kind of make it what you want it to be. If it was like a dot paper or something.
You want to take pictures of my book? You're gonna say no. I wasn't, but okay.
Okay, I'm not saying they're going to be gorgeous pictures, but they're going to be workable. Is that okay?
Yeah.
I'll make sure they're legible. Okay, they're not gorgeous pictures, but they are pictures. Okay, so let's save this. Beep, beep. And what section is this? 10.2?
Yeah.
10.2 homework problems. You guys are lucky. Instead of doing an FRQ, you get to just work on homework. You're welcome. Now, how do I... Oh, save. What? The whole homework? Yeah. Go back and look at my Thank you. I know. I changed my mind. I forgot all the example problems. But then I commented. In Google Classroom before I left yesterday.
I went.
Was it too late?
Yeah. I was like checking homework and then I looked at the calendar and I was like, oh, it says Wednesday. Good night.
Well, that makes sense.
Oh.
Alright, homework problems are coming up in. I have to download and then upload. Come on. 5, 4, 3, 2. Let's see how long it takes to upload. 2.5. 2 3/4.
3, 2, 1.
No, still going.
Even P is between 2 and 3.
0.9, 0.99, 0.99.
This is how you count. This is how it counts in calculus.
Okay, the homework problems are officially up on Google Classroom if you guys want to see them. Once again, not the gorgeous rendition, but it was quick pictures. It should do the job. I'm double checking. Yeah, I think I can see it.
I think Taylor and McLean together. They wrote 26 and 26 also.
Yeah.
27.
I'm pretty sure that's well, number 24 should be the ratio.
Yeah, and power is 25.
Oh, guys, sorry. Let me unfreeze the screen real fast. when you guys see, like, because it's going to look like these are circled, right? Because they are circled. But hold on, in the scanner, just realize it's the shaded boxes. So only go for the ones that have the circles if you're going off of mine. Otherwise, you're going to be doing like every single word, like every single problem. So not every single thing is circled, just in the scan. Those little gray boxes are coming out as circles. Does that make sense?
Yeah.
There you go. So choose the one. I guess you could say with the double circles, but with my circles on top. Discuss calculus? What are we going to discuss?
I know we're doing that tomorrow.
True. What do you want to discuss? What should we Google? We could Google something. What do we want to learn? Okay, what problem?
Is there some work by itself? I have to see if I can see the whole picture.
Yeah. Yeah. Because I want to be here. Why? Do you want me to exist somewhere else? What? How's that sim? You said I'm sitting here no matter what. No, I didn't ask if.
Can I have like a picture of your face?
I didn't say no, that's
I've
why.
been for a long time. Okay. You've been talking for a long time.
Yeah.
Oh, I can't read. Let's see number 1 to
I would have solved it a different way, so Lawrence, I'm curious if it'll end up.
What do I do that makes me a sim? Please explain. Do you want me to just give you
This
the
is your vibe.
Oh, shoot.
Oh, God.
No, I can't be.
The road though.
Literally, like when class started, I was like, "Why are you sitting here?" It was like, "Because I want it for the content." And then you ask him, "Why are you sitting here?" And he's like, "Do you want me to move?" No. Well, I wasn't gonna move anyway. Well, you did say yeah, so I didn't move. Yeah, so I'm not a sim.
Wow.
You offered to move
What?
for her. Well, I didn't move, so.
So she said the number 1 not to divide that, but to divide
Okay.
the 1
Give
percent.
a picture. Give a picture.
What I do? So don't divide.
Wait, that's the homework thing.
Well, you can derive.
So you said not to.
She said something.
So it's not the right thing to do.
Well, it's one of the hard things to do.
So what's this chat?
Oh, is that?
Wait, what was this chat?
You need to take the
This one.
That's right.
What's the story?